All right. So I know I only have 40 minutes. I have about 60 slides. No, just kidding. I actually have a lot of slides. And I'm a fast talker. I don't speak Polish. I was in the session this morning with the two guys from, what are they called again, Dreamlabs? They were amazing. I was sitting in the first row. I had no clue what they were saying, but I thought they were very energetic. And I think they had a great story to tell because people were listening to them. So I will also be talking very fast because I have a lot of content. I know not everybody's a native speaker, so please, if I'm totally going off and nobody understands me anymore, feel free to raise your hand. Even though I also learned over the 2 days that a lot of people don't interact, you try to stay quiet in there. But please let me know. I don't want you to waste your time here. I want to go right into the topic, metrics-driven DevOps. I love metrics because this is what I've been doing for the last 16 years. Right now, you know where I'm working from, Dynatrace, but I'm not pitching the product, but I've been doing something that is interesting. Here we go, we're back. Is this my laptop or is this, no? Oh, good. So I've been analyzing why applications break, why they are slow, why user experience is crappy. And what I'm doing in my role right now, I'm actually telling people what I see out there, large corporations, what metrics to look at, and development teams, how they put metrics into their CI/CD process. And there's different shapes of metrics and different ways to visualize this. This is one way of visualizing a metric. And if you enter our engineering lab in Linz, Austria, that's where I'm originally from, this is what you see in the hallways. We call it the pipeline UFO. You can actually go on GitHub, you can download it, you can 3D print it, and what we basically do, we hook this up with Jenkins, and we visualize the status of the trunk and the latest sprint. Green means everything is good, compiling, everything works, all the tests run through, all the functional tests, automation tests, load tests run through, everything is good. If it is red, if it's totally red, it couldn't even compile. If it's different shades of red, it means more or less tests were executed. And the cool thing with this is, if you're developing and if you check in code and then walk over to the coffee machine and you see that the light is changing from green to red, you know you better hurry and fix the code because you just broke the build. All right? So this is, I think, one metric that is key, and it should be just very visible. Another metric, which hopefully all of you have that are actually deploying apps into production, is availability. Dum, dum. Thanks for the music. That's okay. We always need somebody to pay the bill later on. Thanks for being a volunteer. Availability. If you're deploying an app and the server is pingable, you can ping it, then it's great, but it's not accessible from the locations where your people are, then it doesn't help. So what you always want to achieve is 100% available, but if you make a deployment and then availability drops down to 0, you obviously made a mistake. This happened to Kia, the car manufacturer, last year at the Super Bowl. They're the main sponsor of the US Super Bowl, 1 billion people watching it, and their website went down after the deployment. Not a good thing. Not time to grab a coffee, time to fix things. Another thing, what I'm always proposing, when we deploy software, it's not only about user experience, it's not only about performance, but it's also about resource consumption. This is an example of a deployment where an update of a dependency injection library unfortunately caused increase in memory. So they unfortunately deployed a version of this dependency injection library that had a little bug in there, cost 40% more memory, which means the garbage collector had to kick in much more, increased CPU usage 4x. It had no impact on user experience because the site was still as fast as before, but it consumed 4 times as many CPU cycles. And if we deploy this to Amazon or Azure or any other cloud provider, then at the end, you need to pay a lot more money to actually get the resourcing power. So these are all metrics I think we all need to look at. And not only when you deploy it into production, but already when you do your development and your testing. I'm a big proponent of running unit tests and functional tests, but not only looking at green and red from a functional perspective, but how many objects do we allocate? How many objects stay on the heap if I trigger a GC run? So you can actually figure out how memory and resource intensive is your code. Another example, this was actually just brought into me yesterday. They made a deployment, and after that deployment, CPU went through the roof, garbage collection went through the roof, and we could see that there were much more memory used in the G1, in the heap space, in the Java heap space. Again, they updated software And unfortunately, the software was much more memory aggressive. They had a huge object churn rate. I'm not sure how familiar you are with Java and .NET and all these runtimes, but basically the deployment was allocating millions and millions of string objects because they changed the way they render a report. That means memory usage went up, garbage collection went up, huge impact on CPU. These are all metrics that tell me it's not time to get out of the office and drink a beer or a coffee, but you made something that is obviously impacting your business or impacting your end users. Another thing, this is an example that I recently got. A company that said we want to scale big, so they went from, let's say, a small environment to using Docker and also using Emerson, moving to Emerson EC2 to scale the application. So they said, under regular load, this is how our environment looks like. The visualization that you see here is what we call transaction flow in our tool, but there's other tools out there that probably have something similar. So we basically see requests are coming in, and then they are distributed across the server farm. So they were basically saying, this is how we look like when we run on 10 containers under regular load, and then they tested the whole thing under twice the load. And if you scale perfectly, you would assume twice the load would maximum mean twice the number of containers. But in their case, if you do the math, it's much more. So this is not a scaling system, and you can easily identify that by running a test and figuring out how many containers do you need to sustain the same load, or to sustain the same user experience, the same performance. Which brings me to another topic. Whether you use Docker or any other virtualization technologies, if you build an application that runs on these container technologies or virtualization technologies, you have to figure out right from the start how to monitor. Because just because it's only a mouse click away to spawn 5 more instances, somebody at the end has to pay for it. And if you make a deployment, you need to immediately know, do we now use more resources than before? And if you are consuming more, you need to figure out, was this intentionally, or did we increase a bug that is now causing us to use 50% more memory, 60% more CPU? Okay, these are all regressions that we can detect by looking at the right metrics. Another example, what I'm always doing, we heard a lot about user experience today. The guys from, what's the company name again? The Dream Labs guy? Yeah. I'm sure they have something like this as well, a world map, seeing where do people actually come from. So if you are monitoring your end users and you are deploying a new app and you have your marketing team sending out emails, you actually want to know, where do these people come from? Do they really come from these locations where we want them to be, and what's their user experience? We typically, you'll find this in all tools, red, green, and orange. That's easy for management to figure out if something is red. Screaming, right? So we do the same thing. We basically look at user experience. We monitor how fast are pages, are there any JavaScript errors, if it's for mobile apps, are mobile apps crashing, and if something like that happens, that impacts user experience. And then we can chart it either geographically. We can also figure out which types of, it's a little hard to see, but which types of browsers experience what type of user experience, and we can do our diagnostics on top of it. Here's another example I just got last night, and I wanted to put this in there. A chart. What we do here is actually the top tells us how many users do we have on the system, and this is an e-commerce site. How many users do we have on the system, and the 3 lines here are happy users, middle happy, and actually red, unhappy. And what they also did, they are doing a deployment every night. Every day at midnight, they deploy a new version, which makes sense because that's where the least traffic is on there. And what you could see here on May 5th, not only did they do a new deployment, but they also had a big marketing push, sending out emails to get more people to the website, which was great because what they actually really saw is that overall, the number of users went up and also the number of happy users went up. Unfortunately, at the same time, they also increased the number of unhappy users, and that had a direct correlation with the number of people that actually converted, that actually bought something on the system. And what's interesting for me here is that even though the total number of happy users went up because they spent a lot of money getting more people to the website, these people didn't buy. The people that really bought or were supposed to buy as a total different user group, and these are the ones that actually were frustrated, and they automatically caused conversion rate to go down. These are metrics that can tell you immediately what is the impact of a deployment, and then you can react on it. Right? Another cool use case, this is actually a use case from my own work. So I'm responsible for our community. If you go to Dynatrace and download our free version, you can also get access to our community portal, which is running on Confluence. Confluence from Atlassian, I'm sure most people know Confluence. So in my case, I'm interested in which content do people consume? Are they looking at our online documentation? Where do they click to? So we are monitoring our website, and I can figure out, hey, happy users, that means these are users that have no problem and performance is perfect. They typically consume all of the general documentation, also some of the getting started guides and some of the troubleshooting information. And this whole thing shifts the worse the experience is. So if I go back, this is the good story, this is middle, and this is the people that actually have a problem. And what's very interesting, you can see the people that actually have a problem on the website, they don't consume any content anymore, but what they do, they click on support. That means I immediately know that my website is not delivering the value, so they click on support, which means my support colleagues actually are pounded by a lot of extra work. And I can immediately figure this out by looking at all of this data. Okay? So, I love metrics, as I said before, and you need tools to capture metrics, right? Obviously. I love Dreamlabs. I'm so sorry that I have to re-ask you. They did it on their own. There's a lot of tools out there, whether maybe they open source it, or I think the guys from Zalando yesterday, they said they're open sourcing their solution. There's a lot of tools out there where you can get metrics. If you don't have a tool, obviously feel free. Look at my shirt. You can try this as well. Now, why are people so crazy about the whole thing? Why are people so crazy about continuous delivery DevOps? I think one of the reasons is because of these two companies, right? I guess if I ask you to raise your phone, I have an iPhone. Who is an Android? Shake hands. I'm still your friend, right? I totally left out the Windows users here and the BlackBerry users that are probably no longer really there. What I think is so interesting about these two companies is they started a revolution. And I want to just quickly show you a picture that this was Vatican City in 2005. And what's interesting about this picture is this was when the second to last Pope was elected. There was one guy or one person on the bottom right with a flip phone. 2013, the picture changed a little bit. And if you put it into perspective, it's very easy to see that just a couple of years, the smartphone not only has revolutionized the way we are interacting with software, because I'm sure most of you that have a smartphone, you're using Facebook, Twitter, or anything else, you check your emails. But this also proves that the smartphone not only revolutionized the way we deal with software and interact with software, but it actually revolutionized many other markets. For instance, Kodak and Polaroid, these companies, most people don't even know them anymore. Or I have a torch light on here. I have an alarm on here. I have my GPS tracking system on here. Everything is on here. There's a report that says the mobile phones, the smartphones have totally crushed 38 different markets. I'm sure there's actually much more. So I think this is the new reality, and hopefully we're tapping into this. Who is writing software that is accessible on a smart device? Just two? Come on, really? Well, if you don't do now, I'm sure you will soon. Now, where does DevOps come into the whole thing? I think the promise of DevOps and why these conferences like this one is so popular, because there are companies out there that have revolutionized some of the existing markets. I guess I don't need to explain to you what Uber is. I took an Uber last night from here back to the hotel because it was raining too much. It's great. I can use it actually from my US phone. Works perfectly. And I don't need to pay anything in the local currency. Everything gets automatically charged on my credit card, and it's perfect. So Uber disrupted an existing market. The world's largest taxi company, they don't own a single vehicle, and there's many more examples. This is just a proof that if we are smart enough, we can actually do something much better, even though there might be industries that have been around for a very long time. And I guess I don't need to tell you that this thing is coming up, and we heard many people already talking at this conference about the Internet of Things. We had the guy from Hybris here with his cool gadgets. The guy before this session was also here talking about the Internet of Things. Here's my little example. I recently moved to Boston. This was Boston in February 2015, so last year. Boston is north of New York, and we have a lot of snow. And last year, this was a picture that I took after the third of 7 blizzards that we got. So we had a total of 2 meters of snow, actually, in the end. And why this is important for Internet of Things, because this is very key for insurance companies. Because if you think about it, if you have smart roofs, they could actually detect how much pressure of snow is already on the roofs. And if they talk to all the other roofs around the area and see how the snow is coming in, and if they send data to an insurance company, and an insurance company can actually get that data and say, before we wait 21 minutes until this roof collapses, we tell the firefighters to go to this place first and not to the other building that still has 2 hours. So there's a lot of interesting use cases. The key is, though, if you're writing software for this and the software either cannot handle the load, the data, and it takes 5 hours to process it, then maybe already a lot of roofs are collapsed. Or if you are not doing it because you're an old-fashioned company and it just takes a little while to get these things, then maybe the next generation of Mark Zuckerbergs is doing it. These two guys are 12 and 14 years old, the two youngest CEOs in history. Right? They know how to build a mobile app. They know how to swipe a credit card to buy Amazon or Azure or whatever cloud space to build their apps. They are building educational apps for mobile devices. In their first year of operation, they already have 35,000 paying customers. And the cool thing with that is they can just do it. The only thing they need is a laptop and maybe some money from their parents to buy the first 10 hours of Amazon compute power. All right? So I think DevOps is obviously real, and don't let anybody tell you it's about buying more tools. That's not what it is, right? It's a lot about cultural change and about doing things differently than before. Tools are part of it, but it's not the main thing. I think what people really want is actually getting towards continuous delivery, because for me, continuous delivery is the technical vehicle to getting code changes faster through a pipeline, automated. And I always also recommend that book. I think it should be known by now in the DevOps industry, but if you have never heard about that book, I very heavily recommend that book. Has anybody read it, The Phoenix Project? Yeah? Only 2? This should be up. 3. You like it? Yeah? It's good. It's shockingly simple what the story is, and it's shockingly novel. Yeah. So have a look at it. So the Phoenix Project became really popular, I think, when it was written in 2011, I believe. And this was also the time when the unicorns came on stage at conferences like Velocity, and the DevOps days were started. Because these companies basically said, guess what, we are doing DevOps, or we're doing something that is totally different than what you did before. Right? We're doing not 1 deployment per year, we're doing 700 deployments per year. Or Amazon went on stage and they said, we're doing a deployment into production every 11.6 seconds, which is crazy, right? Why? Then typically the reaction is, why? Right? It's like, why do you do this? Just because we can? No, I think it's actually it's a benefit for them because they can react on change. And it doesn't mean that Amazon.com changes significantly every 11.6 seconds. If you refresh the screen, nothing changes. But we're talking about deployments. A deployment is deploying 5 new Docker containers for the Amazon store in Poland because the new iPhone is coming out and they know they need the compute power. Or they know we need to fix a jQuery deployment because the one we did 2 hours ago broke something on 80% of our browser, on our users on Internet Explorer. And these users are still relevant, but we need to fix it now. And the guys from Dreamlabs, I think they are, even though I didn't understand Polish, but I think they had something on the slide, you're deploying several times a day. They said something like this too. So which is also a proof that it's no longer only the unicorns that do it, but also companies here. And where are the guys from Dreamlabs? Are they? Oh, here we go. You should talk to these guys. They know how to do it. What's also important is don't only think about it's about massive deployment, but it's also about speed. You also brought similar statistics. So deploying something fast is great, but deploying something faster is as even important, because if you deploy something that is very often, but it fails, nobody uses it. Make sense? Okay. So we have all these stories. We have people like them in the room. Still, many people fail, I believe. Many people fail to implement, and I think the major reason is this, right? So who in the room works for a company that has been existing longer than 3 years? Exactly. Most of your companies are probably around for 5, 10, 15, 20 years. You cannot just start with a new project that you download from GitHub and then build your cool stuff on top of it, right? You have your existing processes. And now just telling everybody, hey, we heard about this DevOps thing, and we give just every developer ops power. As cool as this sounds, and as cool as it is, if you do it wisely, in most cases it ends up like this. And I think this slide has also been used in some presentations around in this conference. It only works if you understand that with power comes responsibility. Another thing that DevOps is not about, and somebody also said this, I think earlier today, it's not about installing Jenkins and then everything is cool. Because if you have a process right now that takes a week to run your tests and do your compilation, and they just now automate everything, and if you had problems before, then I think you just have problems now, but even faster. If you build a pipeline where you still have crappy decisions and crappy code coming in the front, and you just automate everything, but you don't have any checks based on these metrics that I showed you before, then you have crap in, crap out, just automated. Yeah. I had a webinar last week with a company called Prep Sportswear. They are an online e-commerce store in the US. They said when they moved to DevOps the first time, 80% of the deployments failed. 80%. Because they automated everything, but they did not look in quality. And they already knew that 80% are failing, so they accepted the fact in the beginning. Right? So it's not about just blindly automating everything. It's also not about blindly adding new features. So if you can deploy, how often per day? If you can deploy 300 times, and potentially you can deploy new features as very often now, hopefully you're not just adding features on top of each other and never asking yourself, do these features actually make sense after a month or so? Because if you just keep adding stuff on top of each other, you know what you get. You get a huge pile of something, and because I'm recorded, I'm keeping my swear words down. But this is what we call in the industry technical debt. You build code, and if you don't even know anymore what is needed and what is not needed, and if you don't have the measures, the monitoring in place that tells you, hey, actually this feature is not needed at all. If you don't have these measures, you cannot take it out because maybe something breaks. So I think we can solve all of this by putting metrics into DevOps. And I love to learn from others. As part of my role at Dynatrace, I actually have a program that is called Share Your Pure Path. So people can actually send me the data that they collect with our tool, with the free version that we have. Customers send me data too, and I see a lot of crazy things. And I want to show you 2 examples which just hopefully open the eyes for you on what you can avoid and should avoid. I know it's a little hard to see here, but this is from an online casino. It's called knockoutcasino.com. This is a guy, he came to me because he read one of my blogs, and he said, Andy, I'm in operations. I'm responsible for that online casino. And right now, I get a new build, a new deployment on the last Friday of every month. Then I deploy it, then typically everything fails. Unfortunately, it's Friday evening and nobody from the engineering side is there anymore. So he, in the operations side, has to keep the servers up and running somehow. And he said, Andy, because somebody read the Phoenix project and all the other books in my management, they now want to do DevOps. And that for them means we are increasing the deployment rate from once per month to once per week. So he was fearing he's getting a new build every Friday, and basically he's the one that keeps the servers alive every weekend. And he said, please have a look at metrics, and if you have never seen this before, I will make this quick because I want to show you the scary numbers. So I looked at this new deployment and I said, if you're going to let this deployment out, then you're forcing all of your users that are going to your online casino to download almost 10 megabytes of content, 282 individual objects, that's JavaScript files and images. It takes about 9 seconds to load. That's beyond everything that the industry sees as fast. And you're also deploying all of these elements, or most of them, from a single domain, from your own server. And if you know how a browser loads a website, it can only either download 4, 6, or 8 things in parallel until we have HTTP 2.0, then things will change a little bit. But this is against every single rule on web performance optimization that we've learned over the years. Another thing that was very interesting, they were choosing a CDN. So one element, they learned somehow that CDNs are cool. So they put a 20 kilobyte CSS file on a CDN. Unfortunately, that CDN did not have any servers in their target market. Their target market was US and Europe, and the server that they chose was in Asia. It was super cheap CDN, but it took 1.8 seconds to get a physical connection. So here's what I don't understand. Production monitoring is important. Looking at this in production is very important, but this should never make it to production. Because if you are a web developer, you should look at these numbers. If you are a tester, don't only look at page looks nice, page looks nice, page looks nice, but look at these numbers too and raise your hand in case these numbers don't make sense. Okay? Now my most favorite example, and this is from a company that grew over time. It's an online sports club search service. Sounds interesting, is cool. So if you are moving, actually as an example from Sweden, if you're moving to Stockholm and you want to send your kids, maybe, I'm not sure if you have kids already, not yet, soon. If you want to go to a football club, okay, if you want to learn football, you go there and you basically search for football clubs in Stockholm, and then you find a list with address, contact details, and so on. Very cool use case. The project was started a couple of years ago as a small project. Over the years, the user base grew very slowly, and then sometimes they said, well, if we want to make this real, then we have to do something. So what they said, we are spending marketing money, and we are expanding into other markets. And what they could also see, once the user numbers rose, they could also see that it's typical, it's called the hockey stick. At some point, the response time goes up like crazy. And they were saying, if we're continuing like this, we probably are going to lose people, because we know all these numbers from Amazon and Google and so on. What we did, they called me in, and what we did, we looked at their application. This is again what we call a transaction flow. So we installed Dynatrace on their environment, and we looked at the number one feature of their app, which was a search. And I want to pick on you again. I know you look like this, but very easy. So the number one thing in their search is football clubs for Stockholm. Why? Football is the most common sport, and Stockholm the biggest city. In early 2015, they figured out that this search takes 2.6 seconds because it's a monolithic app. This was how it used to be implemented in the very early days. It's basically maxing out CPU, and because it's a monolithic app, and in the beginning they never thought about scalability, they said we can only throw so much hardware on the problem, and we cannot scale. So the question is, what do you do with an application like this if you have to scale? What are the options? How do you want to scale this, and how do you want to improve response time? Any thoughts? Another top box on top of it, this would be one option, but they basically said they have a little problem with this database and they never thought about this in the beginning. Caching would be an option, yeah. Well, what they said, why not follow some of the cool new things? Why not break the whole thing apart into a front end that we can potentially deploy into different Amazon regions around the world, because they wanted to go global, that is doing just the rendering, and a backend service that is basically then providing data access through an API. And they can scale it up and down. So that's what they did. The backend team also said, if we want to do this right, we also want to test for it. So the backend team said, we are going to test the whole thing under 7 a.m. in the morning, low load, then ramping it up to noon, and then also making sure that the whole system can also scale down. So this was just done in the backend. And based on this data, they said, we are good to go. We go live. Okay? So on the day when they went live with the new architecture, everything looked good in the morning. So US and Europe was good because that was their main target market. They didn't care about the Australians, not their target market. It's not because they like the Australians, but it's not the target market. This was 7 o'clock in the morning. This was noon. Okay? It's easy to see. For managers, very easy to see. Everything is red. The average response time for the search now was 25 seconds, 60% bounce rate, most people unhappy. Okay? So it's very easy that something went wrong. The question is, what went wrong? And what went wrong was they called me and they sent me the data from, remember the search from football clubs in Stockholm? Yeah? Do you want to take a guess how many football clubs they have in Stockholm? Not the professional ones, but like where everybody can play? Close, 33. Okay. So here's the thing. We looked at the real implementation in production. Again, this is the transaction flow that shows us, hey, the search came in. We know it was really slow. Not only do I always look at performance, but I also look at payload. So how many bytes do we send back? And for 33, a search result of 33, 5 kilobyte, I think is acceptable. What I didn't understand is if this is the front end and potentially this is going to be deployed in different Amazon regions around the world, and this is in the data center in Stockholm, why do they have a direct connection from the code that runs somewhere around the world into the database in the backend? So it's the first architectural violation. We looked at the database statements, and we saw that the initial code was still executing a SQL statement saying, give me the primary IDs, the primary keys of all the football clubs that meet that search criteria. How many? Remember? 33, yeah. So 33, a list of 33 elements came back. In the initial code, when it was still a monolith, they were just iterating over it in a loop, in a local method. Basically, everything was local. Now, they extracted it into a microservice. So basically now, for every single search result, they had one call, 33 in total. Every call was returning 3 kilobytes, so making it a total of 99 kilobytes. They were potentially sent back to the front end, somewhere totally different around the world, and then condensing that down to 5 kilobytes. And what also happened, the way they extracted the monolith into the microservice, the code that they extracted was executing a total of 171 SQL statements. Because now, instead of being called once per search, it was called 33 times, or maybe 50 times, depending on the search query. Again, what I don't understand is, why do we end up with this in production? Because if I am, and I used to do testing in my early days, if I'm a good tester, I go to you because you're my operations guy, and hopefully you can tell me what are the top 5 search queries. Then I can create a test that tests all the 5 search queries, and then I look at how many results come back, what's the size, how many calls do we do here, how many calls do we do here. Then I, as a tester, can immediately see we have a data-driven problem. It's the classical N+1 query problem. We have it between the app server and the database, but also now between services. And this is one of the simplest examples I have. I have examples where we have hundreds and thousands of calls here. Okay. So, looking at these metrics tell me it's not good. So what they did, they fixed the whole thing. They came up with a solution where they had, under peak load, good response time, one call coming into the front end, one going to the back end, 3 database queries. So this was the good scenario in the end. But it took them a while, and it took them a painful couple of days to get there. Here's my message to you and the aha moment that they had. The aha moment for them is, why don't we measure the whole thing earlier? Why don't we start in dev? And here is now a simplified version. I know it's very simplified, but I think something that you want to also implement in your pipeline. I'm going back now to the scenario where they had the monolithic app, and we're talking about 2 key features. The one is the search that we two talked about. The second one is the news alert. News alert is if you are also searching for some sports club, but you don't get the information right now, you can enter your email address. Okay? So we have 2 features, hopefully 2 tests. Whether it's an integration test, an API test, a Selenium, whatever. These tests return green if everything works. What I'm proposing, why not hook up your tests with any tool that can provide you these metrics, like the number of API calls, the number of SQL statements, how many bytes do we send on a wire, what's the CPU usage? Because if we have these metrics for every single test, now I need to pick on you. So you are my developer, I'm your tester, he's our architect. And if we 3 sit together in a sprint review, then I can show I have my tests, here are the metrics, then you, the architect, can say he did a good job, because this right now looks good. Okay? So we deploy it. When we deploy it, we keep monitoring the same features. The gentleman in the first row, you are the guy actually who had the idea. You are interested in how many people are actually using that feature, usage. And you promised to, let's say, our CEO, the guy in the back in the door who is watching, 80% of the people will use the search because that's our #1 feature. It's like Google. If nobody uses search, it doesn't make sense. You say we're only at 63, and probably because under peak load, the response time, the user experience is 5.2 seconds. And you heard from a presentation from Andy that this is not good. So you come back to us and say, we need to fix it. And you also see that news alert is only used by 0.5%, probably also because performance is very slow. So you, the business guy, can come back to us and say, fix it. So what we do, remember, they had the monolith, we break it apart. A couple of builds later, I run my same tests, and now the magic happens for me. If you have the same metrics, then I can immediately say, when I check in my code and I walk over to my coffee machine, and then my little, remember our UFO in the beginning that shows red, because our CI is now smart enough and said, whatever you just did, you're going totally out of bounds. You have 34 API calls, one that comes in, 33 that go back between front end and back end. You have 168 more database queries. You have 20 times as much bytes sent over the wire. You have 3 times as much CPU that you consume. So everybody who is part of that sprint review now, the architect, the DBA, the guy who is responsible for Amazon, they will all say, this is not a good idea. And we don't deploy it. This becomes part of your build pipeline. Metrics that you can make decisions. So what we really do is, we hopefully fix the whole thing. A couple builds later, we run the same thing. Now everything is good, right? We have 2 API calls, one that comes in the front, one that goes to the new backend service, all looks good, then we deploy. And guess what? We want to keep monitoring. Because now the gentleman in the first row, the business guy, you now see, oh good, we are almost at 80%, we're almost there. So we have good performance even under peak load. We are running on 5 containers because we scale up. So we know the costs involved, but it's good. But what you also see, even though we improved performance of news alert to 4.2 seconds now, this had hardly any impact on usage. So maybe that's a feature that you thought is really cool, but actually nobody needs it. So then you can actually say later down the line, if these numbers don't change, you just remove these features. That means less code for him to maintain, less tests for me to maintain, build time is down, everybody's happy. But you need to have these metrics. I know it looks simple, it's very simplified, but this is what metrics-driven DevOps or metrics-driven continuous delivery looks like. And I think I have 2 more minutes. I just want to give you some ideas. Who is a developer in here? Who's developing code every day? Awesome. He can raise his hand. If he writes sometimes code, that's okay. So what we want you to do is, hopefully you are executing your local tests in your IDE. So if you're executing a test, just do it by also capturing metrics. Hook it up with your profiling tools. Hook it up with any tool you have that can tell you how many database statements are we executing, how many bytes do we send over the wire. If you're using Hibernate or any other of these frameworks, they all have logging features where you can log out these details, or use a monitoring tool that can do this for you. Because if you're making a code change, running your tests locally, and then the tool tells you, hey, you're making the same web service call internally twice, why? Then you can say, I don't know. Probably I'm using a framework and I have no clue what the framework is actually doing, but you just tell me it's probably not a good thing. So don't even check in bad code. Then this is a proposal that we use internally and that our customers also use in CI. We detect every single test that you're executing in your CI that is executed by Jenkins, Bamboo, TeamCity, Go. We see every single test. For every test, we look at every single metric, and then we also baseline every metric. Baseline means we learn over time how many database statements should you have, how many bytes. And then if you make a code change from, let's say, build 17 to 18, and the number goes up like crazy, we basically say red flag. From our perspective, it's a regression that potentially later on has a bad impact on performance, user experience, costs that you run. Yeah, also just a reminder, you want to keep monitoring the usage of your features. If you have something like you guys use experience monitoring, you monitor every user, you probably also know which user goes to which feature. So a percentage number is great, seeing how many people actually use a feature. And if that usage number drops, then you want to compare it maybe with load. But you also want to have for all of these features the same architectural metrics. Number of database statements, number of exceptions, number of web service calls. Here's another cool visualization that I like, because we are all visual people. So this is now a visualization in production from the search feature of this company. And what they actually did, the different shades of orange and yellow and green, basically just tell them, hey, how many searches are executed that internally execute between 1 and 5 database queries, between 5 and 10, between 10 and 20. And if they look at it over time, and then you have a deployment at some point in time, and you see the numbers go up and down, you know the stuff that you deployed is not changing the dynamic behavior of your code, and you probably have not caught this in testing. Okay. Yeah. Then, as I mentioned before, monitor your end users, and also think about what I explained in the beginning a little more. Figure out how you can actually analyze user behavior. Because if it's amazing if you're just moving things around, it's very interesting how people change their behavior or how performance really impacts behavior. And this can all be done by looking at the right metrics. And if we do all that, remember the crappy pipeline I had? Crap in, crap out. This is now the nice pipeline. So what I propose, don't even check in bad code, especially code that changes the dynamic behavior. And I know that your code is obviously good, but the code that you write is built on frameworks that you don't control all the time. So that's why it's so important to look at these metrics. Integrate it into testing, into CI, and also make sure that you're monitoring in production. That's our story. And if you do all that, I believe you can build great apps that run 24/7 without any problems. That's it here. But you have to have the metrics. All right. If you have questions, these slides are going to be pushed somewhere anyway on the conference deck, yeah?
Yes, exactly. It's going to be published on the website.
I also have just other links. I have a YouTube channel where I show how I analyze apps. I also blog a lot about it on our blog. Follow me on Twitter if you want to. And the tool can also be get here that I use. And the last thing I want to say, we also have a local partner, Omnilogy. They're out there as well. They had a cool challenge. So if you have more questions when I'm no longer around, then feel free to also touch base with them. And I want to open it up for questions.
Okay. Do you have any questions regarding metrics? There's one over here.
You're my developer, right? Yeah, exactly.
How do you measure how your users are happy or not?
So we call it.
You know them.
Yeah. So basically, you're talking about this. Yeah, we have what we call the user experience index. So we look at two things. We actually have multiple things. We look at response time, first of all. Similar what they do, we inject a little JavaScript file into your page automatically, and then we monitor page load times, but we also understand single page apps. So for every single click that then executes an AJAX call, we also identify these steps. And then we look at response time. We look at any errors, JavaScript errors, HTTP errors. We also factor in your bandwidth. So we do bandwidth detection, and if you, for instance, have a LTE connection, then your threshold is different than one that is constantly on a bad connection because their mindset is a little different anyway. So response time of every single click, any errors, and what we also do, we are monitoring every single click of every single user, so we know the whole user history. And if the user is perfectly fine all the time, but the last thing he does, for instance, trying to check out, and that fails with a JavaScript error, and that's the last thing he does, he's also considered as a problem, the whole visitor. So we have a logic in there that we learned over the years. Fully automated, yeah. It works on any browser. It also works for mobile apps, mobile native apps. And we have a couple of blogs where we talk about this. But we call it the user experience index. Yeah.
Okay, any other question? Regarding metrics? How to do that?
Who is using metrics right now? Good. Did you learn some new metrics today? At least one? That's my goal. Yeah, one metric. And you know, it's very. This is very management friendly. And what's also very management friendly. I know I didn't have it in there.
3 basic colors.
Yeah, 3 basic colors. I think this is actually the dashboard that I had from. Don't hide the slide. This one here. This is actually from this e-commerce customer I talked about. They have conversion rate here, and they also deployed at midnight. And what you could see at midnight, conversion rate dropped to 0 for 2 hours. For 2 hours, nobody was able to buy anything. I mean, they chose midnight because the viewers' traffic. What was interesting, they also saw client errors, so that immediately told the web developers something is wrong because most people are now getting either JavaScript errors or HTTP 500s. They also immediately could correlate it time-wise with, this is server network and CPU. And very important, they are heavily relying on an external API to send email notifications. They use an external service provider. And in that deployment, they made a very simple mistake. They screwed up the URL for the endpoint of that email service. So after the deployment, no emails could be sent anymore. That's why they saw spikes in response time. They just timed out, basically. And the app internally was trying to repeatedly send the same emails. That's why server network went up like crazy. CPU went up like crazy because the app basically ended up in an endless loop. And I think these are the dashboards that were basically used to see the business impact, but also the technical impact right away. Exactly, yeah. Well, in the integration tests, they used a different mocked service that worked perfectly, but in the integration test, they didn't use the external service. Yeah.
But the reason behind it was because it was mocked. If you have like schema change,
Exactly.
everything is mocked. So
I agree with you. Yeah. Unfortunately, not everybody is always perfect, and that's why it's important to keep monitoring in production too. But you're right.